So good morning. We will discuss about the memory. So memory is an important part of an embedded system. The memory used in embedded system can be either program storage memory or a data memory. So any embedded system means it has on-chip memory. Mostly the components on an embedded system are inbuilt. So memory is one of the part of that on-chip. So it has program memory and data memory, ROM and RAM. So certain embedded processors or controllers contain built-in program memory and data memory, and this memory is known as on-chip memory. Right? This is what. Then. So inbuilt. So this is called as on-chip memory because few devices are on the device. So coming to this program storage memory. So basically program storage means we are discussing about the ROM memory, right? Read only memory. So which stores the program instructions. So the lines of code related to CPU, related to ALU, arithmetic instruction, logical instructions. So whatever the functions has to be performed or assigned to that embedded kit, that embedded kit might be executing some arithmetic operation. Maybe another embedded kit may be working in a refrigerator. So like that, different application related embedded kit has its own instructions. Not every embedded system has similar instruction. Depends on the applications. The instruction or program instructions are different, right? It retains its content even after the power to its turned off because ROM memory, you know that. So it's a permanent memory. It is generally known as non-volatile, right? Non-volatile storage memory. ROM memory is a non-volatile storage memory, or you can call it as program memory is non-volatile storage memory. Third point, depending on the fabrication, arranging and programming techniques, they are classified as shown in the figure. So the fabrication means it has 6 to 7 stages. Before the chip going to be manufactured, it has to be went under the process of building the chip. First, it is collected like sand, that is silicon. Then it is passed through the UV light. Then etching, right, to the sunlight and cutting the layers and forming the NPN or PNP like transistor, you know, no? So in which you have to separate that ground, drain, source. So that levels you should, that will be formed in several stages and the chip will be manufactured. So that phenomenon is called as fabrication. So fabrication, very less companies are there in India for the fabrication side of the chips. The next coming point is arranging and programming techniques. They are classified legs. So arranging means sometimes the data might be arranged quickly at a time, or the data might be whatever the content or the instruction which is written in the program memory may arrange line by line or entire total instruction at one go. So it depends on that. It has classified the memories. You could see the central block, this one is code memory, because when you are calling code memory, you are storing instruction in. So coding, all the programs are placed. There is no data in this ROM, read only memory, only programs. and this is a flash memory, and this is the NVRAM. NV stands for non-volatile. Volatile means when power goes, then the data will be erased. Non-volatile means even power goes, the content which is there in this will be permanent. And if you see the categories, PROM, so programmable read-only memory, it is also called as known as OTP, one-time programmable. This is one-time programmable, like CDs or DVD. Once it is used, you can't load again. So the data, once it is stored in that DVD, is a permanent. So you can't erase it, and or you can't use again to load something. Once it is full, it's okay, that data, right? Next, masked ROM. M stands for masked ROM, read-only memory. The third one is EPROM. EPROM stands for electrically programmable read-only memory. The last one is E square PROM. So double E stands for electrically. The first one is electrical, and second is erasable. Electrically erasable programmable read-only memory means a light will be passed on the content, and with that light, the data will be erased. Right? So these are the categories in the program memory itself. The read-only memory itself, it has the categories. How many categories you can see? One-time programmable memory, maskable read-only memory, and electrically programmable read-only memory, and it's also having electrically erasable. So these are the categories in the program memory. So here the discussion is one by one. Maskable read-only memory, what is the difference between these? So it is a one-time programmable memory, uses hardwired technology for storing the data. It uses the hardwired technology for storing the data. So the data will be stored in separately, and this device is a factory programmed by masking and metallization processing according to the data provided by the end user. So as per the requirement, it can be designed. So the primary memory advantage is, the major advantage is for high volume production. Whenever you want to go for high volume of production, means bulk, the large number of storage purpose required immediately. For example, in the election year, right, when they are using EVM, what stands for EVM? Electrical or electronic? Electronic voting machine. EVM. Electronic voting machine. Earlier, 15-20 years back, they used it to ballot papers. They will give one slip to the voter. In that, all the parties, election contestant, their symbol will be there. You have to put your thumb symbol on the respective which you nominate the person, and you should put in the ballot, and they count accordingly that. But nowadays, they are using electronic voting machine. So in that, one time programmable memory is enough. There is no need of permanent memory. Might be used for the record purpose future, they may copy, but the machine can be, once it is the temporarily they can put the memory, depends on the population of the constituency. They use the memory size, so number of voters, just it will count which symbol got how many votes, right? After that, they remove that memory and they replace next election, maybe same machines can be used. And these EVM machines are developed in India by ECIL. Everyone know this. Electronic Corporation of India Limited, the central government defense sector company, are going to develop. We have used the electronic student have the opportunity to work in the ECL company, the central government defense sector. You can look for after graduation for the opportunities in that. You may go for internship, mini project, major project also in the ECL. We have in the Hyderabad also. The last point, the limitations with the MROM, masked read-only memory based firmware storage is the inability to modify the device firmware against to the firmware upgrades. So this is the drawback. So using this, firmware, the masked read-only memory, the drawback is once you loaded the content and you want to upgrade it, the program, whichever it is there, then you can't do that. So this is the drawback in the maskable read-only memory. And this programmable read-only memory, PROM, right? See, how you can store the data, what is the device you are using is semiconductor itself, right? Say transistor having NPN or PNP or a CMOS device may be used for storing. So even 1 bit flip-flops, JK flip-flop, D flip-flop. So each flip-flop has a capability to store the single bit of information. Now they use it for PROM OTP. See, unlike MROM, it is not pre-programmed by the manufacturer. The difference between masked ROM and PROM is it is not pre-programmed. So the user can program it or user can load that in the memory. And PROM can use the nichrome, the material which is used in that component, and polysilicon. So these are the two components can be used for PROM. And you see, fuses which are not blown or burned represents a logic 1, where the fuses which are blown are turned off, the logic 0. So that is once switch is connected, switch is open, that case. And OTP is widely used for the commercial production, which we have discussed. Whenever the large bulk production, you have to use OTP. In the other cases, you might go for the PROM. So it is a low cost solution for commercial production. OTP cannot be pre-programmed, right? But this can be reprogrammed. Now coming to the EPROM, electrically programmable read-only memory. So, sorry, it is not electrical. Erasable programmable read-only memory. Use the flexibility to reprogram the same chip. So once it is used, you can reuse it, right? Please mute somebody making noise. I request you to the candidate, please mute your mic. So the flexibility to reprogram is possible in the erasable programmable read-only memory. So this is only the feature it is added. So PROM is the same. So this E is what? Erasable. So EPROM stores the bit information by changing the floating gate of an FET. So FET is a field effect transistor which can pass more voltage and it won't allows the current. Its input impedance is very high, right? Because of that, it won't allow current through pass it, right? And it consumes very less power. The radiation is very low. That's why these FET or CMOS devices are used in the EPROM, right? EPROM contains a quartz crystal. Quartz crystal. Let me check who is making noise. Right. So, dear student, EPROMs, see, EPROM stores the bit information by charging floating gate of an FET. So FET is used. FET has 3 stages. You are aware of it: gate, drain, and source. Right. So in this also there are 2 different types you can create: NPN or PNP type. So the difference between NP and PNP is sometimes in the competitive exam they may ask the symbol of that arrows inside or outside. If you any PSU exams, they will ask that also. So NPN PNP case, if you are going NPN when the number of electrons are more, basically we are going to pass the charge. So preferable FET is NPN comparatively PNP, right? And the bit information is stored by using EPROM programmer, which applies high voltage to charge the floating gate. So anyway, this passes more voltage through it. So EPROM contains quartz crystal. So quartz crystal window, which is why the quartz material they can use is, the reason is the quartz is can provide a stable voltage, stable frequency, right? A stable frequency it can provide. And the last line is, even though the EPROM chip is flexible in terms of reprogrammability, it need to be taken out of the circuit board and needs to be put in a UV eraser device for 20 to 30 minutes. So to erase the content, you might experience that when we copy something, a larger file, for copying itself, it will take some time. And when you put it in another file, it takes, if the amount of data or information is more, it can take for loading also, right? 1 minute or 2 minutes, depends on the size of the memory. Sometimes you may notice that when you're downloading some applications, based on the size of the file, MB or gigabytes, so the MB will, KB will take less time, MB will take some more time, and GB data will take even 20 minutes, 15 minutes of time. So it depends on the storage, the availability of space it can store. The more empty space easily occupied. If the space is less and information is more, the density of storage is also important. Some compressing is needed. So there are huge topic. This one also, memory is not an easy we are discussing, but the manufacturer knows what is the content, how many bits can store, how the compressed files can be stored. There are so many algorithms to compress the data, right? So here you could see the EPROM. To erase it, you can remove the memory chip and you can place the UV eraser. What UV stands for? Ultraviolet or UV rays. It has very high frequency, gamma rays, I think. And with that light, the light itself, you might be listen that in a heavy heat or in the outside, the farmers they will work no in the fields. The more temperature, due to that, like ozone layer they pass and they can even damage the skin, such more than that UV eraser, the rays will erase the data, even though it will take 20 to 30 minutes to erase the content of the memory, right? So this is about the EPROM. And coming to this, erasable programmable read-only memory. So electrically erasable programmable read-only memory. Right, I'm right. So electrically erasable programmable read-only memory. So this, the difference is the earlier one might take 20 to 30 minutes. It may not take much time because it is erasing electrically. The remaining points are same. So that point I will notice you. See, the only limitation is there. Capacity is limited when compared with the standard ROM. It provides greater flexibility for system design. These chips include chip erase mode, and in this mode, they can be erased in a milliseconds. Please notice this. This point I am searching. So here, EPROM is taking to erase 20 to 30 minutes, but once it is, the feature is added with electrical, then the content of the memory chip, maybe it is different size, KB or MB or gigabyte or terabyte, it took only takes milliseconds to erase it, right? They can be erased and reprogrammed within the circuit. So what is mean by reprogrammed? Reprogrammed means, for example, you are loaded some instructions, particular application, and after that the task is over. Like for example, just now we discussed now EVM, electrical machines. If that chip memory is developed by EPROM, E square PROM, then once the election, every 5 years elections will come now. We can call as general election. All over the country will get the election. During that time, We can't waste no money every year. EVM design also, manufacturing also costly. So only if you replace the hardware setup entire is same, if only you can replace the memory chip, replace in the sense reprogramming that chip, so erasing the earlier contestants voters with the making empty it and reuse it. So such memory you can useful as E square PROM. They can go for this in the EVM machines. So one example I am noticing you this, every device nowadays, electronic devices, automobile, health, now even they are using for health profile in medical side. So various applications, the memory is a very important part. The financial banking related data, weather related report, land records, any field you go, digitalization is there. Wherever digitalization is there, there will be memories are there, right? So these are the things which are huge applications, the memory. And coming to the flash type of memory, right? Program storage memory by using flash. So flash memory is a variation of E square PROM technology. What is the variation? We could notice here. It combines the reprogrammability. You know that reprogrammability means once it is used, you can erase it and you can reuse it. Reprogrammability. Program means what? Instructions. Instruction. So you can erase the earlier instructions and you can load the new instruction. Depends on the application, right? Of E square PROM and the high capacity of standard ROMs. Flash memory is organized as sectors or pages. Generally, you have the memories like DVD or like this, like cells, right? So like these contents will be there in that. So sectors means this. Each sector has unique locations and it can store certain amount of information in this sector. It may store 1 MB memory, it can store 2 MB memory, like that the content will be stored in this, right? Sectors are black means the area, the chip area will be divided into different sectors. Each sector has its unique feature or size. Here I could notice you might see in here cell phone tower, your locality or your village, in your village you may see that. So in that village, if the cell tower is there like Airtel or Vodafone or Reliance, any, what they do is they will divide that. For example, the nearby surrounding 60 kilometers surrounding only, it can detect the signals. After crossing that 60 kilometer signal, it won't read the signal or it won't get the information about that. The persons who are roaming around the 60 kilometers of that village, only that information will be loaded, and even that also categorized in the different ways. 2G mobile, 3G mobile, that case, or might be area, like this area 20 to 10 to 0 to 10 kilometers. This area it can detect 10 to 20 kilometers. This area may detect 20 to 30 kilometers sim. This may detect 30 to 60 kilometers area. So like that they have own partition of that cell tower, right? So in that, like that they are categorized. So this content will store those mobile numbers only. Mobile number means it won't store 10 digit. Every mobile has its own unique ISM number, I think. Am I right? ISM number, no? Some unique mobile number is there that can detect it and that can store and it can enables the amplifies the signal strength. So again, flash memory stores the information in an array of floating gate MOSFET. So this is a metal oxide semiconductor field effect transistor. So floating gate means it's switching. It's not stable or it's not constant. It can switch from one point to other point. As you move the distance, as we discuss here, as you move that, you may change from one cell to other cell, right? If you are currently 0 to 10 kilometers, and after 10 kilometer you cross, you might be reach another cell, another sector. Till 60 kilometer you will run in this. Your mobile network will be in this area. Once you cross the 60 kilometer, there may be another cell tower or another region you may respond. So the erasing of memory. Now the thing you notice here, once the person is crossed the 60 kilometer from that village area, then there is no need of that. Once the person is left out in this region, then the content of that storage is not required. That space is empty now. If somebody come, that will be detected. If no one is there, the space is empty, right? So that is what flash type memory. So the arranging of memory can be done at sector level. So just what I noticed to you, arranging is like sector level or page level without affecting the other sectors or pages. Just right what we discussed, 0 to 10 kilometers, that mobile of respective person will be detected here. Once he cross from 10 kilometer beyond 10 to 20, he will be detected here, the content erased here, right? So like that it will change. So each sector as page should be erased before reprogramming. So this is the case of the scenario of the memory. So coming to this RAM type of memory, so we have finished read-only memory till now and the types of read-only memories. Is it clear? Any doubt in this? Please respond. If it is having anyone doubt about the read-only memory, you could clarify. If not, we'll move forward the random access memory. So read-write memory or random access memory. So another point you should note that the program memory is only for read only, not for the writing. One time only. But RAM, you can read, you can write. So that's what random access memory, and you can store the information or you can store the data in the random access memory. So random access is the data memory or working memory of the controller or processor. RAM is volatile. The meaning of volatile means once the power goes, right, when power is turned off, all the contents are destroyed. So RAM is a direct access memory, meaning we can access the desired memory location directly without the need for traveling or traversing through the entire memory location to reach the desired memory position. Right? You can easily access. So it has read-write memory. RAM is a read-write. ROM is only for reading purpose. So in this RAM memory, you have three categories. One is the static RAM. The second is the dynamic RAM. Third is the non-volatile RAM. So could you notice here what is the difference between static RAM and dynamic RAM? Static RAM you can use the designing of transistors. See, everything this memory is only transistor or FET device, NPN, right? Field effect transistor itself. So in SRAM, total transistors will be used. In DRAM, along with the transistor, nothing but a DRAM can be used photo transistor, and it can has one capacitor. Dynamic means always in the electronic point of view, capacitor only, not only this memory related, any context. Any context, if you get in electronic terminology, dynamic means definitely the capacitor will be there inside the device. And the third is non-volatile random access memory. So this is a crucial, somewhat interesting. Non-volatile RAM means you know that only RAM only volatile, non-volatile. But in the data also you are having the latest non-volatile RAM type. Means even power goes. I'm not putting here UPS or anything, something. The memory itself is a NVRAM, right? NVRAM. Now NVIDIA, the company is there. They are manufacturer of this. So NVRAM, non-volatile RAM, we will go through it, right? So coming to this RAM. So as I notice you, entire or transistor. This is one transistor, the second transistor, third, fourth, fifth, sixth. So these are the 6 transistor for designing what? Single cell. It can store either 0, it can store 1. So this is the SRAM cell implementation. How it will be implemented? You can see the left side node bit line B bar, B complement, here bit line B, here word line. So how it works? You could notice here VCC supply 5 volt, 5 volt supply. Here you can see the ground. So supply, ground, bit line B bar, bit line B, and word line, and 6 transistors, right? So it is a like complementary nature, CMOS complementary. You know that when if you give P type transistor, if you give 0, for example, P type, this is a, if it is a P type transistor, you have a small bubble over here, and this is a gate, this is the drain, this is a source part, source node, drain node, gate node. So if you give 0 to the P type, which type it is? P type. If you give 0, bubble means what is complement? 0 complement is 1. So whenever you give 0 to the P type of FET, it will be on, right? It will be on. If it is N type, then there is no bubble over here. Whenever you give 1, it will be on. Whenever you give 0, it is off. So the static, coming to these points which is noticed in this slide, static RAM stores the data in the form of voltage. It will store data in the form of voltage. Let it be considered quantization values, right? I hope with this slide, I will complete the last one, right? So voltage levels. So you might hear the word quantization. So 0, for example, generally any device, which has 0 to 5 volt. Basically, if it operates in between 0 to 5 volt. If it is noticed that 0 to 1.2 volt, it might be considering 0, and 1.2 more than greater than 1.2 and up to 5. Up to 5 volt, it can be read as logic 1. Then that is in the form of digital conversion. Because in the memory, you are storing ultimately zeros and ones. But practically, memory stores in the RAM is in the form of voltage levels, not zeros and ones. So an SRAM cell bit is realized using 6 transistors, 6 MOSFETs. 4 of transistors are used for building the latch. Latch means flip-flop, right? Flip-flop, you know that it can store 1 bit at a time. Part of the memory cell, and 2 are controlling the access. So 2 will be controlling the access. So static RAM is the fastest form of RAM available. SRAM is fast in operation due to its resistive networking and switching capabilities. So SRAM is fast in operation when compared to RAM itself. RAM and SRAM, among them two, SRAM is the quickest, right? So here you could notice one thing, the cell design. A single chip can be how it is designed. The single bit storage, it has lines, complement and without complement reading, but 6 transistors are used. No capacitors are there inside these. 4 flip-flops are using for detecting bits, and 2 are for accessing the data. Because accessing means some other place you have to collect it for the reading purpose and for the writing purpose. One line for, that is it is B line, B bar line. So B line, if it is reading means B bar line would be writing purpose, right? And word line means it will be detect that whether it is in or out. In or out means what? If you are writing, memory writing means the data will place in the memory itself, chip itself. Reading means the word line will read and pass to the outside device. So this is a word line which is decides whether memory chip is reading or writing. And bit line, B bar line, it will detect based on the whether the data incoming or sending out. You are aware, no? We have discussed interfacing devices, master in, master out, slave in, slave out, like that. So coming to this, with this slide, I will conclude. So RAM is a dynamic RAM, DRAM memory. So as I notice you, DRAM means dynamic. Wherever you hear the word dynamic, you may get capacitor in which. So this is the capacitor. So you know the basic function of the capacitor. Capacitor slowly charges and it also slowly discharges. What is the formula for the capacitor? Q equal to CV, it seems. Right. C is the capacitance, is the voltage, Q is the charge, or Q equals C by V. I didn't know, I forgot very long back. What is the formula for capacitance? Anyone? Anyone? Okay, let it be. We are discussing the point of memory. This is not required for notice. I told you. So here, but once the word line, if it is passed, it will charge. The capacitor also having the capability storing for the longer time, longer life of the information. Because of only that, your memory, even you put something in your file and your system is working after 10 years also, you could get the same file because of DRAM cells. So dynamic RAM stores data in the form of charge. Which form it is storing? Charge. RAM storing which form? Voltage. Please notice this. Static RAM and normal RAM is storing the information is storing the information in the form of charge and RAM is storing in the form of voltage. So they are, because this difference is come because of the element is change, capacitor, due to the capacitor. So they are made up of MOS transistor gates. The advantage of DRAM are its high density and low cost compared to the SRAM. The disadvantage is that since the information is stored as charge, it gets leaked off with time, and to prevent this, they need to refresh periodical. So this is what the drawback. So there is a chance of leakage, right? Because the capacitor and inductors are memory element. You study long back, right? Passive element, no. We can see passive element, resistor, active elements are inductor and capacitor. The reason is they have the capability to store energy in the form of charge. The last line, special circuits called DRAM controllers are used for the refreshing operations. The refresh operation is done periodically in millisecond intervals. So it depends on the storage. You might notice that somewhere data center is there. Like 8 Hyderabad has 5 data centers. Like so that data center is nothing but what? Storage itself. If they are having DRAM, for example, our government of India has 130 crores population's Aadhaar card data that might be placed at somewhere in the country or outside the country using this cell data memories, and that is confidential, right? So it is a confidential data linked to accounts, any others personal data also. So for that purpose, we have to maintain the secrecy in the memory itself, right? So these are the benefits of memory, and the next class we will discuss about the leftover topics, right? Thank you very much.